Hello and welcome to my new lecture on vectors, matrices and arrays for machine learning. These three are essential components for machine learning, and knowing about them help learners to learn in-depth knowledge about machine learning. So let's dive into it. So this is my workspace. I will show you how to create a vector matrix using NumPy library. NumPy is the basic library of Python which allows us to create a one-dimensional array, two-dimensional arrays, and also uh, we can create a matrix object using NumPy array. I will show you later in this lecture how to create matrix object as well. So one-dimensional array, creating one-dimensional array is like create a vector, and creating a two-dimensional array is like create a matrix. So here first I load the library. So the command for that is import numpy as np. As we all know that np is the alias name of numpy. After that we create a row vector. So I write here row underscore vec, which is nothing but the name of my 1D array, then np dot array. Within parentheses we write a square bracket and we write 1 2 3. So these three are the elements of our row vector. Again here we create a column vector, and for that there is a small difference between creating a row vector and a column vector. When we create a row vector we use a parenthesis and a square bracket, but here we use parenthesis, after that a square bracket, and we write down each element within another square bracket. It means that we want to create a column vector, and here is the output for that column vector. And if I run this button, that is import numpy as np, it will load the library. Then I will run this one. I will show this is the output of the row vector, and you can see this is the output of the column vector. Now I will show you how to create a matrix. As I mentioned earlier, there are two ways of creating matrix using NumPy library. As I wrote down here, the first way is using a 2D array, and the second way is using matrix data structure. But but practically we see that we use 2D arrays to create matrix. This is because most of the NumPy operations return two-dimensional arrays as a result and not a matrix object. So using matrix object will create problem when we deal with a real world problems. So here first I create a two-dimensional array, and this will create a matrix. So the name of the matrix is mat2d. After that I write down np.array. Within parentheses there is a square bracket, and each rows is under another square bracket. So 1 2 3 is the first row of our matrix, 4 5 6 is the second row of our matrix, and 7 8 9 is the last or the third row of our matrix. If I run it, I get 1 2 3 4 5 6 7 8 9 in a matrix format. Now for the matrix object, so for that we use the command mat. This command actually supports the matrix data structure, and rest of the comments or syntax will be same as the 2D arrays. Now let's run this one also. So this is our matrix, but you can see here it clearly shows us that it is an array, where it is here it is written that it is a matrix. My next topic is Sparse Matrix. I know most of the learners are not familiar with Sparse Matrix. Sparse matrix is nothing but a matrix with lots of zeros as its entries. So this is the main difference between a sparse matrix and a general matrix. We see that in a general matrix most of the entries are real number, but in the sparse matrix there is lots of zeros which have no use in our programming. So why should we represent those zeros in our memory? It is only overload our memory with no use. This is the reason we use sparse matrix, so that we can only represent real number in the memory and discard those zeros. As we can see here, I show you that there is a sparse matrix with 4 rows and 5 columns, where only 6 are real entries and the rest of the entries are zeros. So there is no need to represent those entries in our memory. So sparse matrix, in the left hand side of the figure we can see how sparse matrix represents these matrix, this 4 by 5 matrix in the memory. So it take the rows and it takes the columns number and corresponding the values. So for the row number 0 and column number 2, the corresponding value is 3. For the row number 0 and column number 4, corresponding value is 4. So it is very efficient way to represent a matrix with lots of zeros. Now why we use this sparse matrix in our machine learning, and what is the importance of sparse matrix with respect to machine learning? As we all know the term NLP, which is represent natural language processing. This is a thriving field in machine learning. In this process, we analyze lots of text, lots of paragraphs. Sometimes we also analyze a total book. So it is very usual that there is very few repetitive words in the book or in the paragraph, and to represent those words in the memory we need to create a matrix for those representation. um, Now if there is lots of zeros, uh, like as I show here, there are two sentences. The girl dances with full of joy and a glass full of water. Now in these two sentences there is only two words that are repetitive, that is full and of. So if I represent these two sentences in our memory using 1 and zeros, so what will be our uh, table representation? I show this representation here. This is the table where there is two sentences, sentence 1 and sentence 2, and uh, if there is a entry for the word the, I write 1 for that word, and if there is no the in the next sentence I write 0 for that. So now if uh, imagine there is 4,000 sentences, and now imagine the size of the matrix and how many zeros are there. So if we try to allocate the whole matrix in our system, it likely that our system will be crashed. So this is the better approach to use sparse matrix to handle this type of problems. Now let's dive into some coding practice. So how to create a sparse matrix? First we need to load a new library for the sparse matrix. The name of the library is SciPy. So I write down here from SciPy import sparse. Then I create a normal 2D array for represent a matrix. Now you can see that in this array most of the entries are zeros. So it is better to represent this array, the two-dimensional array, as a sparse matrix. Otherwise it takes lots of memory space, but there is no use of those memory space. So I create a sparse matrix. Name of the sparse matrix is sparse underscore all, and then I write down sparse dot csr underscore matrix, and within parentheses I write down my normal matrix name. So this is the command to create a sparse matrix, that is sparse dot csr underscore matrix. So first I run the library, then I run the sparse matrix creation. Now if I want to see the representation of the sparse matrix in the memory, so I click on the print sparse all. You can see that it shows that 0 1, that means 0 row and 1 column has an entry that is 1. 1 0, that means row number 1, and row number column number 0 has an entry of 1, this is nothing but this element. Now row number 3 and column number 2 has a entry 3, so this is nothing but that element. You can see that this row has no element, real element, so we cannot get any row number of 2. There is row number 0, row number 1, 3 and 4, but there is no row number with 2. So this shows that the sparse matrix only represent the element that carries some real number and not the zeros. Now we will select some particular element or elements from our vector or matrix. So for that I first need to create a matrix and a vector. So this selecting a particular element or elements from vector or matrices is also called slicing array. So I write down this name within the parentheses as well. So this is our vector. I create a vector and the name of the vector is vec underscore slicing, and the element of the vector is 5, 6, 10, 12, 8 and 2. So if I hit the run button, I got the 1D array with 5, 6, 10, 12, 8 and 2. One thing we should remember that the indexing start in Python from 0. So this is the 0th element, this is the first element, this is the second element, as and so on. So this is our matrix. The name of the matrix is mat underscore slicing, and I create a two-dimensional array to represent that matrix. As I already mentioned that using mat object to create a matrix, it is not a good way of programming, so I create a 2D array here. Now I hit the run button and I got the matrix as well. Now I want to select the second element of the vector. So name of our vector is vec underscore slicing. So which will be our second element of the vector. So let's run it. See, I get element this 10 as our second element. As I already mentioned that the indexing start from 0, so this is the 0th, this is the first and this is the second element. So this is the syntax to access the second element or any other element from a vector is write down the vector name, that is vec underscore slicing, and within a square bracket we just mention the element number. So I want to access the second element, so I mention 2. If I want to access the third element, I just change it as 3, and now I get 12. So see, I got 12. So this is as simple as that. Now I want to select an element from our matrix. So I want to select an element from second row and for first column. So I ran the hit button. I hit the run button, sorry. So I got 8. So this is our second row. As I already mentioned that our indexing starting from 0. So this is the 0th row, this is the first row, this is the second row. So this is the second row and the 0th column. So this is the 0th column. So this is our element. Now if we are looking for another element, let's see, we are looking for 3. So what will be our row number and column number? As you can see, this is our first row and this is also our first column as well. So I will just change it as 1 comma 1. Let's see. Okay, so I got 3. So this is the syntax of accessing element from a matrix, that is the matrix name, and within the square bracket we just mention the row number and the column number. So next is if I want to select all the elements from the vector. So for that the syntax is vector name within square bracket, we just use a colon. So see, this is all the element from our vector. Now if we want to access all the element up to a selective position from our vector, so we want to access all the element up to third element from our vector. So the syntax is name of the vector and the square bracket and then colon and then 3. So if I hit the run button, I got 5, 6, 10. So now if we want to select a certain element after a certain element in a vector, so what will be the syntax for that? Same as here, the vector name and then the element number and after that the colon. So here I want to select all the element after the third element. So I just hit the run button. I got 12, 8 and 2. So this is our vector, that is 5, 6, 10, 12, 8, 2 and the third element is 10. So I got 12, 8, 2 after the third element. Now next, if I want to access the last element of the vector, so there is a nice trick for that in the Python, that is name of the vector and then the squared bracket and then I write down -1. So if I write down -1, it will give me the last element of the vector. See, I got 2. Now if I want to get the first 2 rows and all the columns from the matrix, so what will be the syntax for that? The matrix name, then within the square bracket colon and then we write down 2, which shows that we want to access first 2 rows and then we want to access all the columns. So we just write down colon and do not specify any indexing here, so that we can get all the columns. See, we get all the columns but we get only the first 2 rows. Next one is select all rows and the third columns from the matrix. So as we want to access all the rows from the matrix, so we just write down a colon in the row section and then we write down a comma and we want to access the third column, so we write down 2 colon 3, which will give the third column. So see, we get all the rows and only the third column. We are going to describe a matrix. So first we should find out the number of rows and columns of a matrix. The command for that is mat underscore slicing, which is nothing but the matrix name, dot shape. Now we should know which one is mat slicing. In our previous comment we saw that mat slicing is a matrix that we create here. So this is our mat slicing matrix. We create that matrix using a NumPy array. It is a two-dimensional array. So now we want to know the shape of that matrix. That means the number of rows and columns. If we take a look in this two-dimensional array, we can easily say that there is three columns and 3 rows. Now let's see if we use that, what will be our output. So sorry, mat slicing is not defined here. So first I need to run this cell, mat slicing. Okay, now next, if I run this cell again, I will get the output that mat slicing is a 3 by 3 matrix. Now I want to know how many elements in our matrix. So the comment for that is the matrix name dot size, and it will give us the number of element. As we know that mat slicing has 9 elements, so we got 9. And now we want to know the dimension of a matrix. So the command for that is the matrix name dot n dimension. Our mat slicing matrix has 2 dimensions, so we get 2. Now adding a particular scalar number in our matrix. So how to add a scalar number in the given matrix? There are 2 ways for that. First one is using vectorized class. Second one is using broadcasting method. First I want to demonstrate here how to use vectorized class method to add a number in a matrix. So first I create a function using lambda for adding 100. So for that I write down here adding 100 equal to lambda I colon I plus 100. Then I create a vectorized function for the above syntax. So vectorized adding 100 equal to np vectorized adding 100. Now I am going to apply this function in our matrix so that I can add 100 in our already created matrix. So here our already created matrix is mat underscore slicing. I am going to apply this in that matrix. So I write down here vectorized underscore adding 100 within parenthesis mat slicing, which is nothing but our matrix name, and you can see the output that it added 100 every element of our mat slicing, so that we got 105, 109, 106, 102, 103, 104. But if we going to see our original matrix, which is mat slicing, we can say that these are the original numbers of mat slicing, that is 596234821. So obviously our code add 100 to the each elements of mat slicing. Next we will see how broadcasting method works. So we can add between a matrix and a vector. We can add a number with a vector. We can add a two-dimensional arrays like matrix with a vector. So here I will show you some example of those. So first here I define a one-dimensional array, which we can also call array vector, and the name of this vector is A, and I will add 5 with that vector. So I define here a simple addition operation, that is C equal to A plus B, which will give me the output of the addition of these two numbers. So the output I got is 798 because 5 added with 2, then 4 and then 3, which will produce an output 798. My next example will be addition of a number with a two-dimensional array. Two-dimensional arrays is also known as matrix. So this is like the addition of a matrix with a scalar number, and here is my code, and I will get the output after executing this line C equal to capital A plus B, and I got 393463. Next one is addition of a one-dimensional array with a two-dimensional arrays, and here this is our two-dimensional array, which is nothing but a matrix, and here this is our one-dimensional arrays, which is nothing but a vector. Then I add it here with that command C equal to A plus B, and I got this one. Now I am going to find out the maximum value of a matrix and a minimum value of a matrix. So the name of our matrix is mat slicing. So first I see the values of the element of mat slicing. First I print mat slicing. So I got 596234821. So those are the elements of mat slicing. You can easily see that the maximum element of mat slicing is 9, whereas the minimum element of mat slicing is 1. So now I am using command to find out the maximum element and the minimum element of mat slicing. So our command will be np dot max within parentheses the name of our matrix, that is mat slicing. Now I hit the enter button. I got 9. Now I want to find out the minimum from the elements of a matrix, so our command will be np dot min within parentheses the name of the matrix, which is nothing but the mat slicing. Now I hit the enter button. I got 1. At the elements of our mat slicing is 596, 234, 821. Now for the first row, the maximum element between 596 is 9. For the second row, the maximum element is 4, and the third row, the maximum element is 8. Now if we consider the first column, the maximum element will be 8. For the second column, maximum element will be 9, and the third column, maximum element will be 6. So how could we find that maximum and minimum element of a matrix row wise and column wise? To find out the maximum elements for each column of a matrix, the command will be np dot max within parentheses mat slicing the name of the matrix, and then I write down axis equal to 0, which will give me the maximum element for each column. So I got 8. So 8 is the maximum element for column 1, then 9 is the maximum element for column 2, and then 6, which is the maximum element for third column. Now if I want to see the minimum element for each row, the command will be within parentheses write down the name of the matrix, that is mat slicing, then axis equal to 0. Then I hit the run button. I got the minimum element for each column. So for the first column, the minimum element is 2, for the second column it is 2, and for the third column it is 1. Now if I want to do the same operation but this time for row wise, so what will be our comment? So I write down print np dot max within parentheses name of the matrix, then I write down axis, but this time it will be 1 for the row, and I write down print np dot mean within parentheses the name of the matrix, and axis equal to 1. Now I hit the run button. I got 948. So see why I got it. Here for the first row the maximum element is 9, so I got 9. For the second row the maximum element is 4. Did I get 4? Yes, I did. And I also got 8. So is it really 8? Yes, it's 8. So see, In that way, we can get the maximum and minimum elements row wise and column wise. Now we will see how to find out mean, variance and standard deviation uh, for a data set. NumPy, which is a linear algebra library of a Python, provides us the way to find out mean, variance and standard deviation. But before digging to the coding details, I will like to present you a theoretical view of mean, variance and standard deviation. So here you can see a dummy data set for some dogs and their heights. So our goal is to find out the mean of 5 dogs from that data set. So for a reminder, I will show you the formulas to find out mean, variance and standard deviation. Means is very well known as the average of some number, so it is known as the average. So here there are 5 dogs and the mean of their height will be the addition of those heights divided by 5, so that is 394. Now if I want to find out the variance, the formula for that is sigma square. Sigma is the Greek letter and that sigma square equal to the original height minus the mean for every dogs, and then we will divide it by 5, which will give us 21704. That is the variance. And now we find out the standard deviation. So standard deviation is nothing but the square root of the variance. So we got 147 after square rooting 21704. So this is the basic concept to find out mean, variance and standard deviation. Now we will see how to implement those mean, variance and standard deviation using NumPy. Here I will share with you how to find out the mean from a matrix. So the command will be np.mean. Within parentheses, I would like to write down the matrix name, that is mat underscore slicing. So this is the mean for mat slicing. Now if I want to find out the mean value for each column of a matrix, the command will be np.mean, within parentheses the name of the matrix, that is mat slicing, and now the axis, that is equal to 0. So I got 5, 4.67, 3.67. Those are the means for each column. So 5 is the mean for this column, 4.67 is the mean for this, and the rest one is the mean for the last column. So next one is the variance of a matrix. How could we found that? That is np.var, within parentheses name of the matrix. So this is the variance of the matrix mat slicing. And now we want to find out the standard deviation of a matrix, that is np.std, stand for standard deviation, and then the matrix name, that is mat underscore slicing. So The standard deviation is 2.62936879248871. Thanks for watching. See you in the next video.